This is Josh White with JW Math Tutoring. Today's video is going to look at 10 problems from the Digital SAT August 2024 math section. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin going through part 3 of these August 2024 Digital SAT math questions, just a quick little reminder, most of these questions are probably multiple choice on the actual test, but because we don't have all the answer choices that the students remembered, and obviously I don't have a copy of the test, I'm solving them as free response. So there might be other methods you could use if a question was a multiple choice question and you actually had the answer choices in front of you. Okay, so just be aware of that. And of course, the second thing, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications, and of course, if you have any comments or alternate solutions, please do leave them below. I'll make a video about any good alternate solutions that I come across. All right, so starting off with this first one, this is a fairly tricky one that I've seen a number of people post about. So basically, this function is positive between a and b. Okay, so a is a 0 or an x-intercept. B is also a 0 or an x-intercept. Same thing with c. Okay, so a, b, and c are all x-intercepts or zeros, roots, whatever you want to think about them. All right, and then we also have some point on this graph, r comma s, whatever, and they're saying if s is equal to 6, so this point is really r comma 6, i.e. a positive y value. The fact that it's 6 is irrelevant. It's just the fact that it's positive is what's relevant. Okay, which of the following could be true? So there's multiple ways that you could kind of think about this and figure it out. There is kind of like there's a theoretical way, there's a way using the graph. I'm going to do it by using first of all, by picking numerical values for A, B, and C, because I think it's easier to work with that instead of a bunch of letters, floating around A, B, C, R, S, blah, blah, blah. So I'm going to choose just A equals 1, B equals 4, okay, C equals 5. So now what I can do is, first of all, I'm going to get the graph of it. So that's good. And getting the graph is going to help me visualize, what exactly is going on here. All right, so here is the graph, okay, of our function. Basically, here's our, A value, you can think of it, here's our B value, here is our C value. All right, now, first thing to check is when x is between A and B, in this case between 1 and positive 4, is the function positive? Okay, yes it is. You can see it's, it goes up here and comes down, but the y values are all positive. All right, so that condition is met. Now, if s equals 6, which of the following could be true? So in other words, if you have a point value here, which has a positive value of 6, so notice there are technically multiple places where this could be true, okay? There's this right here, there's this one right here, and there's also this one right here. Notice the first two are between A and B for the x value or the r value. Notice the third one is to the right of C or greater than C, okay? Let me just get rid of these because it's confusing. Right here, this point right here, 5.4 and 6. The 5.4 is to the right of or greater than the C, which is right here at 5, 0. So when you go through these answer choices, R is greater than C, yes, definitely possible. What about between B and C? Well, if we go back to the graph, is it possible to have a positive value between the B value and the C value? Okay, and the answer is no, it is not. And the reason is because the shape of this graph and the fact that it's a cubic polynomial and the end behavior and the fact that the leading coefficient is positive, which means it has to be going down on the left and up on the right. So therefore, because of that shape, because it's positive between like A and B here, it has to then be negative between B, and C. So this one will not work, and it's going to be the same thing with the first answer choice as well. If I go back to the graph here, basically to the left of A, it has to be going down, okay? Because A is positive at 1 and it has a multiplicity of 1, that means the graph is going to cross there. It's not going to bounce or it's not going to touch. So if it's positive when x is greater than A, i.e. to the right of A, then it has to be negative to the left of A when it's less than A. So that would eliminate this one as well. So that's how you could get this just by kind of like picking some numbers and looking at the graph. But here's an alternate way to kind of think about this or visualize this using signs. So, and again, I'm going to just pick numbers here. And actually for this example, I'm going to make b equal to 3 instead of 4. Then I'll show you why in a second. So all the conditions are still met here. If you go to the graph and I just change this to 3, okay, notice like same exact conditions are met. It's still positive between A and B right here, and so on. Okay. So now what I would do is I would look at the signs. Okay. So I'm going to pick some values just to plug in for x that fall in each of these intervals, and then go ahead and see what the signs are. So for example, R is less than A. So again here, A is 1, B is 3, and we said C is 5. So let's say you plug in 0, for example, for A, or excuse me, for R here. So first, R is less than 0. This is the R is less than A interval. Okay, notice 0 minus 1 is going to be negative. I'm not concerned with the value. I'm only concerned with is it positive or negative. Then we do it for this one. 0 minus 3, that's going to be negative. Here, 0 minus 5, that's going to be negative. The 2 out front is positive, so the end result, negative times negative times negative, the overall end result is a negative value. Therefore, could the y value be positive 6? No. Do the same thing for R is between B and C. The reason I shifted this to 3 is now just so that I can use a whole number. I can use 4 instead of, if I had 4 and 5, I would have to use like 4 point something to go between them. So again, the 2 out front is positive. 4 minus 1, that is positive. 4 minus 3, that is positive. But over here, 4 minus 5, that's negative. So positive, 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 but we have one negative. Therefore, the overall end result would be negative. We can eliminate this one. It's not going to be correct. Now we'll pick one for where R is greater than C. So let's say R is equal to 6. So we've got the positive out front still. 6 minus 1 is positive. 6 minus 3 is positive. 6 minus 5 is now positive. It's all positives all the way across. Therefore, you could have a y coordinate of 6 because when it's greater than C, it's going to be a positive value. So that would allow you to, again, eliminate these two. It's going to be this one only. Correct answer for this is going to be letter C. Next up, question number 2. In this situation, you basically have, two parallel lines here, and then you have a transversal. And so notice here, you technically have 8 angles, 4 at each intersection point, and 2 of them are acute, vertical angles, and then 2 are obtuse. So if the acute angle is 6x minus 620, so that would be right here, 6x minus 620, this one also 6x minus 620. You could also label the same things down here. And then they also tell you that the sum of 1 acute and 3 obtuse is blah, blah, blah. This with W, what is W? Okay, so the first step is realizing that one of the acute and one of the obtuse together have to add up to 180, okay? Because they together form a straight line. So the measure of the obtuse angle is going to be 180 minus whatever the measure of the acute angle is. So that's 6x minus 620. Or in other words, if you simplify this, let's see here, it's going to be 800 minus 6x. So that's the measure of one obtuse angle. Now we take one acute, 6x minus 620, and 3 obtuse, so 3 times the 800 minus 6x, and we set that equal to negative 12x plus w, which we're given. All right, so now we just have to solve this for w, and basically what you're going to see is the x's are going to cancel out. Plus 2400 minus 18x, and then of course that's equal to the negative 12x plus w. And so notice here, 6x minus 18x, these two combine and make negative 12x, and then that's just going to cancel out with the negative 12x on the right. You know, if you want to add 12x, both terms will drop out. So the value you're going to get for W is just 2400 minus 620, or negative 620 plus 2400, however you want to think about it. W is going to turn out to be 1780 for this problem. So that's pretty much, I mean, the only way I know to solve it. I don't know of any other shortcuts or like tricks to get that one. All right, next up, question number 3. They want you to solve this equation for the letter Q. So this problem, just so you know, this is a multiple choice problem. You know, it's going to be impossible on a free response to type in exactly, an equation and stuff as compared to specific numerical values. So I'm still going to solve it though, as it is a free response question, and also show you what a trick you could do if it is multiple choice, like if multiple choice and you had the answers in front of you, how you could also do it as well. So the straightforward way, traditional way to solve this is basically going to be to multiply everything by the common denominator, which is QPRS on both sides. That's going to clear out all the fractions. And so on the left side, you're going to have 23 PRS. And then on the right side, you're going to have 3 terms. They're all going to be 23, but they're going to have, basically 3 of the 4 letters, because one of them is going to cancel out. So the first one's QRS. The second one is going to be QPS. And then the third one, let's see, the S's cancel, so it's going to be QPR. Now we want to solve this for Q. That means we need all of the Q terms on the right side. So all we have to do is now basically factor a Q out over here. That's actually already done. Notice all the 3 terms with Q's are all on the right side. So we can actually just do the next step, which is factor a Q out of all these terms. And now we got 23RS plus 23PS plus 23PR. And then go ahead and divide by this on both sides, 23PRS. So you're going to end up dividing by 23RS plus 23PS plus 23PR RS plus 23PS plus 23PR. Again, this whole thing cancels out, this whole thing cancels out. So this is your final answer right here. Again, this is going to be a multiple choice question. It's impossible to enter this as a free response because it's not a numerical value. But the students don't remember all of the answer choices, from the test and everything, and I don't have a copy of the test. So that's why, I'm doing this as a free response. Now, here is one way you could do that for multiple choice. Here's an actual strategy or technique you could use. So what we would do is we'd go to Desmos. Okay, you're going to type in the formula. Don't worry about adding sliders just yet. Now, the variable that you're asked to solve for, which in this problem is Q, I'm going to change that to Y. I'll explain why I do that in a second. The rest of the things we're going to add sliders for. So, okay, they do it as one, like, let me just go to the default zoom here. They do this as one, like, I'll just show whatever. I'll change one of them to 2, one of them to 4, and one of them to whatever, 8, let's say. Okay. So now, notice for those values, basically what's happening is Desmos is solving this equation for Y. because whenever you type in a formula with an x or a y in it, Desmos will automatically attempt to solve that for the x or for the y. So in this case, since it has just y, it's solving for y. That's why it's a horizontal line, okay? And it's some value up here, you know, at like between 1.2 and 1.4 something. Then what you would do is you would type in basically your answer choices, and you would type them in exactly as they're given. So for example, instead of Q, of course, we replace that with Y, but everything else would stay the same. So notice for this answer choice, it overlaps completely. It matches the given horizontal line I got from typing the original function. Okay? So like here, here. Take this away, nothing happens. You know, same. So that was what confirms this is the correct answer. It looks like it's actually at 1 point. Oh, this is not 1.2 and 1.4 because it's 1.5. It's 1.1 and 1.2. So I misspoke a little while ago. So if you had other answer choices to check, so let's say you had an answer choice that was just like, say you could just flip it and it's like, you know, whatever, PRS divided by 23. Okay. So, okay, obviously that's not right because if you notice, let me just unhighlight this one, notice it's not the same line as the original. The original is this lower one, this new one is not the same as it. So that's what tells me that this answer choice right here is wrong. And let's say you had like, I don't know, PRS, like everything was the same for an answer choice, but it had no 23 on top. Okay. Again, notice here, it's not the same as the original line. That's what tells me that it's wrong. It's incorrect. Okay. You need to have the two. Basically, what you're doing here really is equation matching or expression matching. So, the way you could do this in Desmos, but the multiple choice problem is, again, just to review, you type the original formula or the original equation. The letter that you're solving for, which in this case is Q, you replace that with Y. Notice you could also technically do it with X, and you would just be looking at vertical lines for each thing. If you didn't want to do horizontal lines, you could do vertical lines as well. Like that's fine. But I typically just use Y for horizontal lines. So then you go through the answer choices. Then next you add sliders for every letter besides the one you're solving for. So in this case, that's P, R, and S. Move them to whatever numbers you want based on the conditions of the problem. Then go through your answer choices, type them in. Remember to replace, you know, the Q or whatever with the Y, and you're looking for the one answer choice that completely matches or overlaps the line that you graphed initially, the initial equation that you graphed. Okay, so that's how you could do this in Desmos, basically when you're solving a formula for a one specific letter. All right, next up, question number 4. We have here basically a rectangle, and the area of the rectangle is increasing at a rate of 1,080 centimeters squared per hour. So we got 1,080 centimeters squared per hour. So this is just a unit conversion, but the thing is you are converting two different units. You're both converting the centimeters squared to meters squared and also the hours to minutes. So you have to do two different multiplications here. I'm going to do the hours one first. So we got 1 hour is 60 minutes, and then the hours would cancel out, and then we have something per minute, which is what we want. But we also have to do the centimeters squared to meters squared. So you can either do 100 centimeters and 1 meter. You can either just write it twice. And the reason you have to do that is because it's an area, because it's two-dimensional, whereas the 100 centimeters to 1 meter is a scale factor that's one-dimensional. So you have to do it twice, basically to account for the fact that it's an area. You know, like think of it once for the length, once for the width. So you can go ahead and you can do this, and if you multiply it out, it's going to come out to 0.0018. So there's technically two different ways you could write this. Actually, no, 3 different ways. You could do it like this, 0.0018. You could also do 0.001 which would technically be truncating it. You just truncate off the 8, or you could do 0.002 if you round it up. The 8 rounds the 1 up to a 2. So either of those would be acceptable as well. I don't think you can enter this one as a fraction because you're not going to have enough spaces. And just to confirm, so you got 1080 times, just to show the calculations, 1 over 60, and then times 1 over 100 times 1 over 100. Okay, so there's our answer, right? And now if we just convert this, so you get 9 over 5,000. You don't have enough characters to enter that in. You would do 9 divided by 5, that's 3, and then 0, 0, and it would stop. Because this is 6 characters, but it only allows you 5 for a positive number. So you would have to enter this as a decimal. You cannot enter it as a fraction. Next up, we have a question where I've tried to construct this one based on the description the students gave. I didn't, no one actually drew a picture of this, but I think it's something similar to this. You're told that the diameter of the smaller inside circle here, from C to A is basically 18. No, diameter. So that's sorry, not C to A. The C to A is a radius. It's the full thing, here all the way across. And you're also told the shaded area is 403 pi. And they want to know the length of this line segment AB here. So this one is, it's a tricky question, but each of the individual steps themselves are not tricky. It's just putting all 4 or 5 steps together that is difficult. So we know the diameter of the inner circle is 18. That means the radius of the inner circle will be 9. 18 divided by 2 is 9. So the area, I'm going to call it of the inner, or you could call it the white circle, is going to be pi times 9 squared, 81 pi. All right, so in here we've got an area of 81 pi. Now we can add that to the 403 pi area of the shaded part, and together that would make up the entire large circles area. So if you do that, we should get 484 pi. Then, now that we know that, so we know the area, not really the outer, it's we call it the whole large circle, right, is 44 pi, and that's equal to pi r squared. So the pi's, of course, will cancel out. So r squared is just 44. So we can just square root that to solve for r. The radius of the large circle is going to be 22. So that means, from here to here, or from C to B, however you want to look at it, that value is 22. So now to get AB, you're just going to subtract the inner circle radius from it. So in other words, AB is just going to be the 22 minus the 9 inside here. So the length of AB is just going to be 13, and that would be your answer to this problem. Next up, question number 6. There are multiple ways that you could do this one. So one way would be to just first set up a triangle here, just call this angle A. We know tangent of A is opposite over adjacent. So technically, if you notice here, to get from this side to this side, you're multiplying by square root 3, because root 3 times root 3 is just root 9, which is 3. That means that this is a 30, 60, 90 triangle. 30 here, 60 here. Which also means that this hypotenuse would be just 2 root 3. Now, you don't actually have to use that, but anyways. So which of the following could be the measure of A in radians? So basically, you're looking for, which of these angles is equal to or equivalent to 30 degrees or pi over 6. If you do it in radians. That's basically what we're checking. So there's multiple ways that you could think about this or that you could check this. So when these questions come up, what I tell my students to know or to memorize is that if you think about this, okay, over here you have 0 and you have 2 pi. Up here you have pi over 2 which is also the same as 0.5 pi. Over here, you have pi, or really 1 pi, and down here you have 3 pi over 2, which is same as 1.5 pi. So basically, it's like what you want to look for is like this is basically like even value pi. This is odd value pi. This right here is going to be even plus 0.5 pi. And down here, it's odd plus 0.5 pi. So I take the first thing, answer choice 1, 61 over 6. Let me just do it down here. Okay, go to Desmos and just divide that. It's 10.17. So where is, and again, that's just approximate. So where's 10.17 going to be? Well, it's going to be between 10 pi and 10.5 pi. Okay, so it's going to be here in quadrant 1. And specifically, if you take this and you subtract, 10 pi from it, you're going to be left with 0.166 whatever repeating, 16 repeating pi, which is equivalent to pi over 6. So this one checks. Now, for the second one, take negative 71 pi, over 6. Take negative 71 over 6. We're going to divide that. That's negative 11.83. Okay? So first thing I would do is negative 11.183, blah, blah, blah. I would add this just to make it positive, to make it easier to think about. So if you add 12 pi to this, in other words, go back to Desmos, take this value, add 12. We're just ignoring the pi. Notice it comes out to the same 0.1666666. Okay? So this angle right here is equivalent to pi over 6, which is what we're looking for, the 30-degree angle. So this one basically works as well. Then you take 3 and you do 59 pi over 6. Notice this one is 9.83333333. So 9.83, well, repeating pi. So where's that going to be? So it's going to be like 9 pi would be right here. 9.5 pi would be right here. 10 pi would be over here, like all the way back around, at the start. So that means 9.83 is going to be somewhere between 9.5 and 10. So this is going to be quadrant 4. This is not going to be equivalent to, pi over 3, or excuse me, pi over 6. So this one doesn't work. So the correct answers are going to be 1 and 2. Now, that took a little while, to explain, to go through, might be too difficult for you to understand, and that's completely fine. So here's possibly a quicker, easier way to solve this in Desmos entirely. All right, we know that the tan of the angle A is root 3 over 3. So if I take square root 3 over 3, it's equal to this number. All right? Let's just make sure I am in radians. Okay, I am. Well, actually, no, it wouldn't matter for this part, but it's for the, okay. So now all I'm going to do is I'm going to take the tan of these angles, and I'm going to see, do I get square root 3 over 3? Okay, so the first one, yes. For the second one, yes. For the third one, no, I do not get root 3 over 3. You technically get negative root 3 over 3. That's what this is. But so notice 1 checks, 2 checks, 3 doesn't. Therefore, 1 is correct, 2 is correct. And that's technically, that's all you have to do for this problem. You can do it in Desmos in 20 seconds. Okay, next up, question number 7. Here we have a function. This would probably not be equal to 0. I'll fix that in the document. And you're told basically that the product of the roots, or the product of the solutions, so this function is equal to KRS. And what's the value of K? So for this problem, all you need to know is the shortcut formula that the product of the roots or solutions or zeros to a function, quadratic equation, is going to be equal to c divided by a. So this is c and this is a. So we take rs and divide it by 45, and we set that equal to krs, what it tells us, and then just solve this for k. So notice all you have to do is divide by rs on both sides, cancel, cancel. You're left with just a 1 on top. K is equal to 1 over 45. And that's it. That's the correct answer. You don't need to do any other work. You could type, you could enter it in as 1/45th, or you could enter it in as 0.0222, 1, 2, 3, 4, yeah, 5 spaces, or technically 0.022. So either one of these three forms would be equivalent, but that's it. That's the entire problem. All right, let's see here. Next up, question number 8. You have 12 people that went to a webinar. So the first webinar, 1,250 people. And then of those, 64% went to a second webinar. So 64% went to a second webinar. Okay, and then 32% of the people who went to the first and second went to a third. So whatever this number is, which then 32% went to a third. Of those who went to the first but not the second, which would be basically 36% over here, because you either went to the second or you didn't, so these two percentages have to add up to 100, so that's where the 36 comes from. 34%, so this is some number, also went to the third. Okay, so from here to here, basically 34% of that value went to the third. How many people went to both the first and third webinars but not the second? Okay, so on this one, all we have to do is calculate, first of all, 36% of the 1250. So that's going to be 450 people. And you could actually, just so you know, with percentages too, you could actually type it in like this if you want to. But anyways, it's 450 people went to the first but did not go to second. So this is number of people that went to the first but no second webinar. Now, of that group of people, 34% also went to the third. So you're just taking 34% of the 450. And it's going to be 153. So down here, it's going to be 153 people that went to the first webinar and the third webinar while not attending the second webinar. And notice that this 64% thing, technically we need to know what the percentage is in order to know how many percent that did not attend the second, but we don't actually have to calculate the value for the number that went to the second. Or this 32% here that went to the first and the second went to the third, that again, that's completely irrelevant. We don't need that in any way at all. All right, next up, question number 9. So we have a room and has an area of 5,200 square feet. I'll just make it rectangular, even though technically, we don't have it listed in the question thing. So total area 5,200 square feet. And an architect makes a model of this where each side is 1/20th the side of each side of the floor. Okay, so it's a smaller square model, and basically what's the area of this square model? So there are two different ways you could do this. First, you could just pick some numbers for the original floor size, like some easy numbers to work with. Like I chose 20 and then 260. The reason I did that is because when I multiply it by 1/20th, I know that 20 times 1/20th is going to be a nice easy whole number to work with, nice integer. So if the floor was 20 by 260, well then the model would be 1/20th. So 20 times 1/20th, it's just 1. 260 times 1/20th is 13. So what's the area of the model? Well, 1 times 13 is just 13, and that's the final answer. Alternate way to do this is just take the area, 5,200, and you're basically going to divide by 20 squared, or really multiply by 1/20th, but you have to do it twice because you have to do it once for the length and once for the width because area is two-dimensional. So it's really 5,200 divided by 20 squared, which is 400. And you can see, and that just comes out to 13. So that's just an alternate way to think about it. But you could get the answer doing that as well. All right, last question on this digital SAT August 2024 math problem set part 3. This one is very, very similar to a problem that was in part 1. The work and pretty much is the same until the very end. In the part 1, I think it was asking for the height. This one's asking for the volume, so it's just like one extra step, but the overall process is almost identical. So you have the pyramid with the square base. Okay, and you know the total surface area is 3920. You know the lateral surface area is 2320. The lateral surface area is the area of the 4 like triangular faces up here, but not the base. So you just subtract these two numbers to get the base area. Usually it's B in the formula. And if you do that, you just get 1600. So that means the area of this square base is 1600. Therefore, if you square root that, the value of each side will be 40. Okay, so the square, that's the base, is 40 by 40. Base area is also 1600. So we'll come back to that because we'll need the volume formula, which is 1/3 times the base times the height in a little bit. All right, so next we have to find the height. The way we have to do that is basically, so the height is here. You have to set up a triangle and you make a right triangle where you have the height and then the hypotenuse is the slant height, which I usually call L. And then this side down here is basically half of one of the sides of the base, meaning it's 20, not 40, because it only goes half the way across. So in order to find the height, we need to know L, the slant height. The way we get that is we look at one of the triangular faces, and we know that the base will be 40, all the way across down here, and then this height, which is the slant height, is L. We're going to figure that out using the fact that the total lateral surface area is 2320, and we divide that by 4 because there are 4 triangular faces to get 580 square meters as the area of one triangular face. So in other words, 580 is equal to 1/2 times the base times the height, which is the slant height here. So if you go ahead and solve this out, this is just basically 20, divide by 20, divide by 20. The slant height is equal to 29. So now I can go back here, I can replace this with 29. Now you can use Pythagorean theorem to find the height. H squared plus 20 squared equals 29 squared. It's going to be H squared is 841 minus 400, or in other words, 441 for H squared. Square root that. H is going to be 21. Okay, so the height of this pyramid is 21 meters. Now we go back to the volume formula and we just plug in the area of the base, 1600. The height, just found it to be 21. So you could cancel this out, you could just type this onto Desmos. Basically, it's going to be 11,200. That's what cubic meters, that's what you get for the volume. So 11,200 is the correct answer. All right, I hope you enjoyed this third problem set, Digital SAT Math, August 2024 questions. If you have any questions or comments, feedback, alternate solutions, please do leave them below. If you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. If you haven't done so already, check out part 1 and also check out part 2. Otherwise, good luck in your preparation for the Digital SAT Math section.